tic-tac-toe program. So for this, we have a slide that says, let's create a tic-tac-toe game. Using our IDE, you will be making a tic-tac-toe game. The end result will look something like the visual below. So it looks like here we have a small example of how the game would run, like in a little, command window terminal. And so player X, turn number 1. So player X, enter your move, row 1 through 3, column 1 through 3. So we would obviously have to print this statement out. And then next we have player O, turn number 1. So player X, enter your move. So right, we already read that. And then the player types in the values 1, space 1. So this clearly indicates that we're going to need to accept user inputs. That's something we also need to keep in mind. And then we print out, this whole tic-tac-toe board with the location of where the X should go that, player X said they wanted their X in. And then player O, enter your move, row 1 through 3, column 1 through 3. And we just sort of, continue on this order. We print the board. Player O, has their O on the board now, and so on and so forth. And we have some helpful hints. So the first helpful hint is to create a class called tic-tac-toe, which makes sense. That's a very good name to give this class. Hint number 2 is there will be user input. So like we said, we definitely need to accept, the numbers that people type for, where they want the row and the column placement of their X or their O. What should be a field versus a variable within a method? So this is something we'll get into a little more once we think about the problem a little better. But obviously some things we are going to want to keep as, a field for the whole static tic-tac-toe class, whereas other things we might just want to keep track of internally within a method because, it's just something very local and it'll be used, for one quick second and then be sort of tossed out. So for a field, for example, we might want to keep the, if we're thinking that the board, right? So for example, the next hint is what will hold the values of the 3x3 game. So in my mind, if we're thinking of a board, we're just thinking of a multi-dimensional array. So we would have a 3x3 array, right? And we want to be able to access this multi-dimensional array in any of our static methods. You know what I mean? So we don't want to have to only have it in the main class, and we don't want to necessarily have to pass it in as an argument to every method. It's much more convenient to just have it as a field for a whole class to access whenever it needs to. And another field, for example, that we might want is we might want to keep track of whose turn it is. So that's something else that could be helpful to keep as a field, whether it's X's turn or O's turn. But we'll get into, a little more of that as we start coding. And so we already talked about, 4, we'll hold the values of the 3x3 game. So 5, what actions will need to occur? So methods needed to create. Okay, so this is a good question. So we need to think about, what kind of steps we're going to need to, have, I guess, in our main method to accomplish the job of, running this game. So in my mind, when I'm thinking of the main method, and when you think of the main method, this is like what's putting all the, other static methods together. So it's like your floor plan, your little plan of what's going on in the game. So I'm imagining in the main method that we're going to have a loop, probably I'm thinking most likely a for loop. And I'll explain why a for loop in a second. So we know that it's a tic-tac-toe game. In a tic-tac-toe game, it's a 3x3 board, and there are 9 slots total to, either place an X or an O in. And so because of this, we only need to have a loop that goes over, that goes through and says, okay, player X, it's your turn, player O, it's your turn. We only need to do that 9 times total. Because, otherwise if we do a 10, then at that point, you're not going to be able to place an X or an O anywhere because the board is going to be filled. So we know that there's going to be a loop of that, kind. And, after the loop finishes, for example, that means the whole board was filled. And so we need to think about how to handle, okay, so how do we declare who won the game or who lost the game? Well, there's a few ways of going about this. In my mind, I think we can just we can leave it as we can make it as simple as just letting the player determine that on their own, or we could have a method that specifically, the entire job of that method is just to check the, the board array that we have and say, okay, is there a winner? Yes, no, and if there is, who is it? But the other thing we can do is we can also just leave this up to the player, and after the 9 turns, just say, check the board, the game is now over, check to see who has, three in a row. Whoever does wins the game, has won the game. And after that, the game can just automatically reset. And I think that method is probably, the simplest and most straightforward, so I think that's what we're going to go with. And so, in talking about that, we've actually sort of already answered the 6th helpful hint. So what will reset the board back to empty? So in our case, we're just going to reset the board back to empty once the 9 turns are over, which, it makes a lot of sense. It's straightforward. And so now in terms of methods, so now that we know that, how we're going to let our game run, and again, speaking of that for loop that we have in the main method, that's going to run 9 times for each slot on the board. The methods we're going to want, first we're going to want to definitely initialize the game. So, that might involve some things like clearing the board, setting the player, back to X. Let's say X just, always goes first, just for simplicity. We could also, write some more fancy code, and we could try using math.random to randomly determine, whether X or O starts the game. But we'll keep it simple, and we'll just say that X is always reset to be the first player. And, you do things like that in the initialize game method that we would have. And then another method that we would want is we would want some sort of method to actually print out the entire board. Because this is going to be something that we want to do after every turn. After we accept user input, which is going to be its own method that I'm going to go into in a minute, we also want to be able to print out the board each time. And and so another method that we're going to, want to have is something that accepts the user input. So we're going to want a method where we just call the method and it accepts the user input within that method, and it updates this, the board, the internal, solution of the board. It updates it and it places an X, hypothetically speaking, where the X needs to be placed. So, and that's generally what we're going to need to be able to accomplish this tic-tac-toe game. And we actually have one final slide to help us out, so extra helpful hints. So it says here, if you're still struggling, consider using method headings below to get you started. These are not necessary, just a suggestion. Your method names could be different. So, we have some similarity with the ones we just came up with. So for example, they have one here called Init Game, so we definitely are going to have one like that. And in fact, the little comments that they put in match up with what we said we would do in our init game. So initializes board squares to empty, sets the first player, public static void board, so prints out the board. We definitely are going to have something like that too. And they have these other 2 methods. One is current player, returns player selection. So I'm guessing current player has something to do with, grabbing the user input, and current state determines current cells chosen on board. So I guess this one does some sort of setting of, the values on the board. But either way, we don't have to have these. These are just suggestions. So we're going to go with the suggestions I made, while talking on the last slide. Okay, so I think it's most likely going to be helpful to keep this slide open, right? So this gives us, how the game should look, while we're playing it. So it's good to have that visualization. And let's switch over to the JGrass window to actually get started on the code. So the first thing we're going to want to do, so remember, I said earlier that we're definitely going to want user input. So let's just get that out of the way right now. So, I have a new file opened up here on JGrass, and we just want to do an import, so java.util.scanner. And of course, don't forget your semicolon. And then we're going to add a new line. And then now we can start declaring the actual class itself. So public class. And of course, we'll call this tic-tac-toe. Then we need our curly braces. Okay. And now I'm just going to go ahead and just sort of run through the methods. So I'll just declare the main one first because it's the most familiar one. So public static void main string array args. And we need our curly braces. There we go. Okay. And next thing, so now we can actually start with the methods that we talked about. So first one is going to be public static void init game. So this is going to be, our initialization. So this is where we reset the board and, essentially set everything back to 0. And I'll just add in a new line for now. And then after this, we want to have another method. So I guess the printing one we could just write up. So public static void. And again, it's void because we're just going to be printing. We're not going to be, returning any sort of values. So I'm just going to call this one print board. Okay. And let's see. So next we have another method. So public static. And right, so for this next one, what's left? We discussed that we want to have a method that grabs the user input and updates the board. So for that one, I don't really think we're going to have to return anything, to be quite honest, because the way we described our game, we're just going to go through the loop, the 9 times, and at the end, just let the player determine, who won or who lost. So I think we could just, it's just going to return void. It's not going to return anything. So public static void, and we'll just call this, what could we call this? We could call this update game. It's a pretty, that makes sense. And it's going with the theme of the init game method. They both end in game, so it sounds like a natural thing to call it. So update game. All right. And, let's see. Public static void update game. And then I think are we missing a method? So we need a method to update the game. We need a method to print the board. We need a method to initialize the game. I think we might actually be good on the methods that we need. And surprisingly, yeah, they're all going to be void. Because, the two main things we're going to need to keep track of are the board itself, which we're going to declare in a minute as a field, and also whose turn it is. So is it X's turn or is it O's turn? Okay, so now we can actually go ahead and, move on to the actual declaration of the fields. So, okay, so like we were saying earlier, our board is going to be a multidimensional array. And we have to think about how we have to think about what type we want this to be, right? So I believe there are two straightforward options. It could either be a string multidimensional array, right? And, if it's a string, obviously, then, the slots of the board, the squares, would just be populated with the string X or the string O. Or it's also possible to populate it with just, plain integer values. And you can just, map particular player to a particular number. So for example, it seems really natural to say that, player O is represented by the integer 0, and player X we can just say is represented by the integer 1, just for, simplicity. So I think in my case, I'm just going to go for an integer array, because I think integer arrays are just, generally easier to work with. And, since we're not doing anything too complex, that really necessitates strings. Like maybe if we had to store like whole names in the slots, then obviously, mapping integers to names, it gets a little tricky. So we'll just stick with an integer array since it's just X versus O. It's like a binary thing. So public static, and we're going to want to declare this as an int array, and we'll just call this one board. Makes sense. And the other thing we have to consider is, so we're declaring public static in board, and we're going to initialize this value within the init game. So we're actually not going to, say, public static in board equals, new, etc., etc. Instead, we're just going to put a semicolon there and then actually initialize the value when we call init game. Actually, you know what? No, you know what? Actually, it might make more sense to actually initialize it because we could even have within a init game a small for loop that just goes through and resets all the values. So I changed my mind on that actually. So let's say equals new int array and the size. So, oh yeah, that's right. So we need a multi-dimensional array. So see, I almost forgot this. So we need to do int array board equals new ints. And so for this, it's just going to be a 3 by 3 board and then semicolon. Okay, so now the other field we are going to need for our, our entire class is going to be public static, and we need to, figure out what player, whose turn it is. And for this, I think it makes the most sense to use an integer representation, just like we're doing for the board. So we already said that player O is going to be 0, player X is going to be 1. So we can do, the same thing for keeping track of whose turn it is. So public static int, and we could even just go ahead and call this whose turn. And this equals, and so we said we're always going to initialize it to x, so x is 1 in our case, so we're going to say x, whose turn equals 1. All right, so now we can go ahead and, there's two ways of going about this at this point, in the code. So we have all our methods mapped out, we have our fields mapped out. The next thing we would want to do, we have two choices. We can either go into the nitty-gritty right now with the methods, and go method by method and declare, exactly what needs to happen in each. Or we could go to the main method and, just lay out the generality of what's going on. So I think I'm going to start with the main method because it makes it more clear when we code up the steps within the main method of what each particular method is supposed to do. So let's do that. So in the main method, like we said earlier, we're definitely going to want a for loop. So for, and we'll just write that out now. So for int I equals 0, as long as I is less than 9, I plus plus. And then of course we want our curly braces. Okay. Right. And so we have to consider for this if we want, so if we're going to want to reset after the 9, then what does that mean for us for our main method? Yeah, so it means that, the way we originally talked about it, we would go through the loop, and then at the end of the loop, we would have some code that would reset the game. But we have to realize that if we reset the game, we're not going to be able to go through the loop again. So you might actually want to control that resetting within the loop itself and just check the values of I. So we might want to say, if I equals 0, then reset the game, or rather, if I equals 9, do your regular update, but then at the end of the for loop say, okay, if I equals 9, then that means we have to reset the game all over again. If that makes any sense. I think it should make sense. We initialize the game again, and we even can, manipulate the value of I and set I back equal to 0. But of course, if we do that, you need to keep in mind that we're definitely going to have to we're going to have to make one call to initialize game, so init game, before we go through the for loop to set up, the array and everything else that we need. So to do that, we're definitely going to want to call init game once. So yeah, we could just put that directly before. So init game. And then within the for loop, we definitely want to be checking at some point if I Well, not 9, my mistake. I said if I equals 9 earlier. What I really meant to say is if I equals 8, because remember, we're going up to from 0 to 8, not from 1 to 9. So if I equals 8, right, we want to reset the game. So to do that, we want to call init game. And we also want to say, we want to set I equal back to 0. And then the way someone would be able to, cancel the game is at some point, or even, one possible way of going about it is we could accept user input, but I think the easier way, to keep this problem simple is we could just say that, the user could, quote unquote, end the terminal, so just stop the entire process that's running, for this program. And if they stop it, then that's the end of the game. But otherwise, the game just always resets back to, a plain board where you can, start typing in. Okay, so we have that set up. And then within the for loop itself, we're going to have the actual code above this if statement that, processes the game. So we've already initialized the game, outside of the for loop. And then the next step we're going to have to do is we're going to have to print some stuff out. So the first thing we're going to want to print out is a statement saying player blah, enter your move. So to do that, we would have to print it out. So system.out.println. And we would want to print out, so player and then we would do that player plus. And so the thing we have to keep in mind is that for whose turn we chose an integer, so it's going to either be 1 or 0. So you know what? Now that we're actually coding it up and printing out the strings that we need to show the user, it seems to actually make a lot more sense to keep whose turn as a string, because it'll be much easier to just, add it to the string within the standard out statement. So let's actually go ahead and change that. So whose turn will now be a string, and we'll always start off with x. So whose turn is a string, and it's x. So then player, and then we'll say whose turn. And then we need our single quote. Okay. Whose turn, and what else do we want after the single quote? We want a comma. Enter your move. Row 1 through 3. Column 1 through 3. Okay, and then we need another parentheses, and then of course we have a semicolon. And actually I put down println when I should have put print, so the user can just type in, their user input right next to the statement, and then we can print the board nicely below. So I think that makes a little more sense. And then of course at the end of this print statement, don't forget that we need to close it with a double quote, parentheses, and a semicolon. All right, so that's going to print out, okay, player blah, enter your move. So now we're going to need some code, like we said earlier, that asks for user input and stores that value into the board. All right, so for this, we will just simply call our method update game. So update game, semicolon. And then after we update the game, we're going to want to print the board. Makes sense, right? And believe it or not, that's actually kind of everything we need for our main method. It's pretty strange to think about, but this is really all we need. You see, I don't know if you see what I mean, but there's not much else that we're going to need to, continue with the main method. So we initialize the game, we go through 9 times. Each time we say, okay, player blah, enter your move, update the game is going to collect the user input, and it's also going to, store the user input into the appropriate place on the board. Then we print the board so the person can see the board. And then once we reach the very last turn, so after we've processed the turn, updated the board, and the board is now filled, we reinitialize the game and we set I back equal to 0, because then this will start the loop over again. All right, so something we might want to do is, even though it's very clear to, us what's going on in this main method, it might not really be clear, believe it or not, to other people. So it's very useful, for other people. It's very important for other people to understand your code, to have a good explanation of what these methods do. So the update game, the initialize game, the print board, because otherwise, they might get a vague sense of what's going on just by looking at the method name, but they're not going to understand it fully. So that's something we definitely want to do. We want to add comments above these methods. And another thing is, too, we might want to, definitely explain why it is that we're checking the value of 8, because it might seem a little strange to some people, who didn't necessarily go through the thought process with us. So we should add a comment here and explain that game has reached last turn. So reset the game board and the loop. So now people can understand this is just like basically saying, okay, we've reached the end of the game and we're resetting everything to play the game again. All right, so now that we have written out our main method, we should add comments above our other methods. Okay, so let's add our comments. So add a space there, and I prefer to use, the double slash, double forward slash comments, so that's what I'm going to use. But, you could use the other methods of commenting. So for init game, so what did we say init game is going to do? So init game resets the board with values that do not correspond to either X or O, and resets the player to X. Okay, so remember that when we talked about our board, we said that the value 0 would represent O, and the value X would be represented by, or rather X would be represented by the value 1. So what this means is that when you initialize, an integer array, whether it's, single dimension or multidimensional, it's going to initialize every value to 0. So right now it looks like our entire board is filled with the values that represent O. So it's like O played all 9 turns for some reason. So to avoid that, we need to just create, a short double for loop that goes through the board and sets everything to a neutral value, a value that doesn't represent O, and it also doesn't represent X. So, a simple value that you could just choose for this is -1. It's negative, so it's entirely different from the other two values, and it's very, easy to identify. So let's make that for loop. So for int I equals 0, as long as I is less than board dot length I plus plus, and then we need our inner for loop. So for int j equals 0, as long as j is less than board I dot length I plus plus. Okay. And actually, we should add a comment, above this double for loop just to explain exactly what we're doing. So need to set all values of board to -1, which is a value that does not represent either X or O. Okay, perfect. So now we can go ahead and fill in the actual for loop. So what we would want to do is board ij equals, and so we want this to equal -1 for every value of the board. So now after that is done, we also want to set the whose turn. So whose turn equals X. And I think that's pretty much all we need to do for this method for the initializing the game. So it's pretty straightforward. Okay, so now for printing the board. So this one's going to be a little interesting. So in terms of explanation, I think we can actually get away with not writing a comment for print board because it's it's very straightforward. The name of the method itself explains exactly what's going on. So we're just going to go ahead and start actually writing it. So for this, what we're going to want to do is we're going to definitely want a double for loop because we want to iterate over every value of the array, right? So let's just start writing up that double for loop. So for int I equals, 0, as long as I is less than board dot length I++. And then, of course, we want to go back within our for loop for int j equals 0, as long as j is less than board I dot length j++, and curly braces. Okay. So, right. So when we're within this loop, right, the double part, so right here where we are right now, we're going to be going over the values of a single row. So what we want to do is we want to say if, because we're going to need an if statement to, check the integer value and whether it corresponds to, the appropriate, type of thing that we're looking for. So if board ij, so there's 3 values it could be. It could be 1, 0, -1. So we'll check, for each one respectively. So if board ij equals 1, then we know that's X. So that means what we want to do is we want to print out an X. So we'll just say system.out.print, and remember print because we don't want to start a new line yet. That's going to be saved for later. We want to print X. Okay, so now that we have printed out the X, we need to, of course, put in our other statement to check if the value is, if the value is a 0, which represents an O in our case. So else if board ij equals 0, then what we want to do is we want to do a system.out.print, and we want to print an O. Okay, and then the last thing we want to do, so else, if it's not a 1 and it's not a 0, then that means it will just be a space. So we would just print out system.out.print and just a simple space. Okay. So at this point, we have the code that will make sure that an X gets printed out when it should, and O gets printed out when it should, and a space gets printed out when it should. Another important thing we definitely are going to need is spaces and these bars. So if we think about what's going on right now, each row requires 2 bars. So effectively, what this means is that after, no matter what we end up printing out, within this section here, let's say it's an X, then we need a space followed by a bar. If it's an O, we need a space followed by a bar. If it's a space, we need another space followed by a bar. So that means within this for loop, but after, outside of this if, else logic, we need to include another print statement that says system.out.print. And then we need to include a space followed by a bar. And the bar, that's just something on the keyboard. It should be on your keyboard at least. So, and then parentheses and semicolon. Okay, so now this will cover us for the, a row of whatever it is we need to print out. But then, of course, after we print out these values of the row, we need a new line to start a new row. And additionally, what's important to keep in mind is that after each row that we print out, we also actually want to print out a set of, I don't know if you can tell, but they have this like set of dashed lines. Essentially, I think all they really did was just use, just regular dashes. So to do that, what we're going to need to do is print it out on its own new line, right? So the dashes, because there's no, straightforward or easy way to underline text when we print it out. So instead, we're just going to put these dashes on their own new line. So to do that, it doesn't make sense to include that code within this inner for loop, because if we do that, what's going to happen is when we get to the very last row, right? So this row right over here, we're going to print another set of dashed lines right below it, which we definitely don't want. So instead, what we will do is we will do it directly after this for loop. So directly after this for loop, we want to do a few things. We want to start a new line. We want to print the dashed line on its own line. And then we move on to the next row. But of course, this will actually still end up with too many of these dashed lines. So what we can do is, outside of this for loop, we can just do a little bit of a check where we say if I is board.length minus 1, or rather, if I is equal to board.length minus 2, meaning I is on its second to last. No, my mistake. I keep messing up what I'm saying. I mean, cut that part out. Cut the part out where I say if I. So if I equals board.length minus 1, that means we're on the last iteration. And for that last iteration, we want to make sure that we don't print out the set of dashed lines. We just want to print out a new line. And so to ensure that, we can actually check to make sure that I is not equal to board.length minus 1. So we could do the following. We can say if I is not equal to board.length minus 1. We should put some parentheses around this just to make sure that it's very clear, what it is we're doing. Curly braces. So if it's not board.length minus 1, then we want to print out the dashed line. So system.out.print. And I guess let's just put 1, 2, 3, 4. I'd say 3 times 3 is 9. 9 plus 2 is 11. I would say 11 dashes should cover us quite well, but I'll put in 12 just to be safe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That should be 12. And, oh yeah, that's right. For this, we can actually do a print ln. And then before this, we need to also just print out one new line. So we could just, we could do that like this using, the /n. And there we go. So this should print out our board in a really nice and neat way. In fact, we could even do a little testing on just the printing of the board, but nah, let's continue because we only have the one method left. So we might as well save the testing for once we finish coding everything. One thing we do want to do, though, for sure, is just add in a comment, maybe right above this little section of code so that people are clear on, what's going on here. So yeah, let's just write in that comment. So always add a new line after printing row, but only add a dashed line if only add a dashed line after the first and second row. Yeah, that makes sense. So it makes it a little more clear about what this code is doing, because, someone just looking at it, without having, necessarily watched the videos might think, that this is a very strange piece of code, but this will make it clear. Okay, so now we can actually go ahead and move on to our update game method. So for this, we're definitely going to want to have a comment directly above the method that explains what update game is actually going to do. Just like we did, up here for init game. So the comment that we want to add above update game is we want to make it clear that we are going to ask for user input about where to place X or O, and then update the board accordingly. So that makes it very clear how exactly we're going about updating the game. Oh, and my mistake. Accordingly, also update whose turn. Right, because we want to make sure we change the turn of, who, what player goes next. Because otherwise we're always going to be letting X go over and over again. Right, so we want to ask for user input. So the best way to do this would be to create a scanner object. And one thing I will admit is that if we decide to create the scanner object inside this update game method, what that will mean is that every time that we call update game in our main method here, we're going to be creating a scanner object and then, essentially discarding it, creating a new one, discarding it, creating a new one, discarding it. So it might make a lot more sense for this method in particular to actually pass in the scanner object and create the scanner object in the main method. So that way we're not essentially, having this kind of inefficient code. So let's do that. So it's going to accept an argument, and it's going to be a scanner object, and we'll just call it in, for system.in. And then we'll create the scanner object over here. So scanner in equals new scanner system.in. And remember, this is in the main method. And we want to make sure that we pass it through to update game. So in. Perfect. And now we can go here and write our code, with the scanner already created for us. So if the scanner has already been created for us, what we need to do is we need to accept the two integers that a user is going to type in. So we'll declare our first int, and we'll call this row. So int row equals in dot next int. Don't forget your semicolon. And int column equals in dot next int. There we go. And now what we want to do is we want to change the value in the board at row column according to whose turn it is. So remember, whose turn for us, we decided ultimately to use a string. So we're going to have to do a little bit of, string checking here. So essentially what we want to do is we want to say if whose turn is X, then we want to set the value on the board as a 1. And if the string is an O, we want to set the value on the board as a 0. And then, yeah, so let's go ahead and do that. All right, so if, and then, so we have to write out, let's see, so it's whose turn. And remember, for strings, what we want to do is we want to use a special method, and that method is equals. So if whose turn dot equals X, oh, whoops. And the only other value that we would ever set whose turn equals to is, of course, O. So we can actually just use an else here instead of an else if. And we should probably add some new line space. Yeah, that looks nicer. All right, so if whose turn equals X, then what we want to do is we want to go into the board and access the row, the column, the ones that were, specified by the user. And something important to keep in mind, actually, before we continue, is that when we ask the user for a row or column, we specifically tell them to assume that the rows and columns start like the index from 1 instead of 0, which is how they actually start. So when you take in the values, you should expect, numbers from 1 to 3. But what we want to access the board array, the multidimensional array, is values from 0 to 2. So all you really need to do for this is just subtract 1 from each value. And you can actually just do this within the brackets themselves, like I just did right now. So board row -1, column -1 equals, and you want to make sure to set this equal to a 1 for X, because that's what we're using to represent X. And then just semicolon, and then for else it's going to be very, very similar. It's just board row -1, column -1 equals 0. Okay, so now we have accepted the user input, we have updated the board accordingly, and now we need to also update whose turn. So we can actually also do this within these if-else statements. So if whose turn equals X, that means after we set the value, we need to say, okay, well, whose turn is now equal to O. And of course, don't forget your semicolon. And then, very similar to that, for the else statement, we would put whose turn equals X. All right, and that should be the end of our code. Yeah, because we don't really need to do anything else within our update game method. So all that is really left is to test out whether our code actually works or not. And to see, if it works the way we expect it to work and the way we talked about, how it would work. Okay, so now we can go ahead and save. I already saved earlier, so that's why I didn't get the pop-up window. Then we can press Control B to compile. All right, so we actually got a compilation error, which is okay. Let's just read what it says and figure out where it is. So it says line, oh, whoops. I accidentally pressed the key. It says here, tic-tac-toe.java 49 error parentheses expected. So if we actually click on this, it should take us right to the error, and it looks like it kind of did, because if we look here, whose turn dot equals X, and we totally forgot to put the closing parentheses for the if statement. So hopefully that'll fix our problem, so we can do a Control S again, Control B to compile. Great, that looks like it worked. So now we will be able to do a Control R to run. Oh, we actually ended up getting an error. Let's see. So it says here, exception in thread main java.lang.array index out of bounds exception 3. And in particular, we have the error for init game on line 13. So if we go to where this shows up, or not line 13, it just says, oh, my mistake. Yeah, it is init game. Whoops. Whoopsie. Okay. So if we go to init game, it says there is an error with the index. That is interesting. Ah, look at this. We made another silly error here. So instead of writing J++, we wrote I++. But that's okay. It was pretty easy to find this error and fix it. So hopefully that will fix that. So Control S, Control B to compile. Compiled, good. And Control R to run. All right, now we have our actual game running. So player X, enter your move, row 1 through 3, column 1 through 3. Great. So I'm going to put in 1, 1, just like the example. I'm actually just going to go exactly through the example shown. Okay, so let's check if it printed correctly, and that looks pretty good. The only thing that I'm noticing right away is we have a little bit of a problem here. Instead of just having, 1, 2, 3 slots in each row, we have 1, 2, 3, 4 slots in each row. But this might be a pretty easy to fix problem, and I have a suspicion about what the problem is. So yes, it looks like my suspicion was definitely correct. So we are printing out this bar after either an X, an O, or a space, which is fine, but what we have to realize is that for the very last one, so if we look at the very last slot, there's no bar after it. So to fix that, we're just going to have to use, an if-else clause. And essentially what we want to say is that, remember, this is part of the inner for loop in our print board method. So essentially what we want to do is check to see when the value of j is not equal to board I or board bracket I dot length minus 1. So as long as j is not the last value, then we want to print out this bar situation. But if it is the last value, then we do not want to print out the bar. So we can just go ahead and write that up. So if j is not equal to board I dot length, we need our curly braces. Then we need to take this and cut it out. So Control X, delete that extra little new line, and then add a new line in here and Control V to paste. And that should fix the problem we're seeing in our, with our print board method. So let's check to see that it works. So Control S. And so here we can just clear and end it. That'll end what was running. And so we already saved, so now we can Control B to recompile. And then Control R to run again. Okay, so player X, enter your move. Again, this looks correct. So let's just put in 1, 1. Okay, now let's check to make sure. This actually seems to have not fixed the issue, because we're still getting 1, 2, 3, 4. We're getting 3 bars on each row when we really should be only getting 2 bars. How silly of me. I actually forgot that we want to be checking for this, code, this if statement that we just added, that board I dot length is not, or that j is not equal to board I dot length minus 1. Oh, whoops. There we go. And of course, don't forget the closing parentheses. So now this is what we meant to do. Let's save our file. Let's compile with Control B. Oh, okay. So I forgot to stop the running program here, and it's just asking me if I want to end, run, and continue. So I'm gonna choose that option. Okay. So we compiled and with no problems, and then Control R to run again. So again, we have the text that we expect. Player X, enter your move. Okay. So I'm going to choose 1, 1. And this is good. So we're looking much better now. It looks like perfect. We no longer have 3 bar symbols on every row. Although it looks like we could reduce the number of dashes we're using to make the dashed line. Although it really isn't necessary. It's more of just, a visual thing. And, having a longer dashed line isn't going to, make any... it's not going to have any negative impact on how the program runs. So we'll just leave it for now. So now, in the example they gave, they said they wanted player O to choose 2, 2, so we'll do the same. So 2, 2. All right, this is looking pretty good. But we did encounter something. So if you notice here, our O, again, this is a visual thing, but I would say a bit more of an important visual thing. It looks a little weird because we have the O directly next to the bar without a space in between it. And this is actually a pretty quick, easy fix. And the fix for this is just that we need a space after the bar in this code over here. So we just add a space like that. So Control S to save, Control B to compile, and again, this is that window that popped up last time, so you can just say end, run, and continue. Okay, compiled successfully, Control R to run. Okay, so player X, enter your move. So let's do what we did last time, 1, 1. And just like last time, we're looking pretty good. No issues there. And then player O, enter your move, so 2, 2. There we go, that looks nicer. Okay, so, and now we can just sort of, continue the game. So I am just gonna, play the game like I would normally, and I just want to, see what it looks like and make sure that once we filled in all the spaces that the game resets itself. So let's just check to make sure that that happens. So we filled in 1, 1, we filled in 2, 2, and I guess let's just go in order and fill in all the other, slots of the game. Because remember, we didn't add any code to check if a player won or not. And that is something you're more than welcome to do, and you could set it for yourself as a little challenge. And, if you do decide to do something like that, I would strongly suggest that you have a separate method, because it's a little separate piece of logic, I would say, and it deserves its own little method where, you're just accessing the board array and checking, okay, do I have a row of just X's anywhere? Do I have a column of just X's anywhere? Do I have a diagonal of O's? That sort of thing. So yeah, like I said, I'm going to continue. So I'm just going to put in 1, 2, and let's make sure that put it in the right spot. Yep, definitely did. So 1, 3, again, looking good. Okay. And then we'll do 2, 1. Perfect. And something to keep in mind too with this code that we wrote is we haven't included any code to check whether what the user put in is valid. And when I say valid, all I really mean is that, obviously when X places, it's I guess it's X on, spot 1, 1, that doesn't mean O can come in the next turn and place an O over that X. But the way our code is written right now, they can do that. If you want, again, as a challenge, you could add in this type of code where you're checking, okay, I received the user input, let's check the board and say, or rather, I received the user input, it's at this row, this column. Let's go to the board at this row and this column. Is there an X or an O there? No? Okay, then let's put in that person's request. Otherwise, maybe you could print out something saying, please try again. Or you could just end the game claiming that foul play was being used. It's up to you. But it's a challenge that you could set for yourself. Right, so anyways, where was I? So, right, so we filled in 2, 1, 2, 2. Let's fill in 2, 3. Perfect. And then let's fill in the last row. So 3, 1. And then we can fill in 3, 2. And then we can fill in 3, 3. And there we go. So as you can see, we filled up the board. And then as we expect, we loop back around. And it says, so we do have player X enter your move again. Okay, so that means that we definitely hit the update game method even after we filled in the 9 slots. Now the question is, did the board clear out? So let's fill in, whatever. Let's just choose 3, 3. And perfect. So it looks like the board did definitely clear out with all blank values except the one we just put in for this new game. So something else that you're definitely welcome to do is you could even add in some code, after the game ends. So if we go down to the main method in this code here where we reinitialize the game, you could very well, if you wanted to, print out a little statement that says, new game has started, and then print out the, player X, please enter your move, and then so on and so forth. So yeah, that's all. And definitely, if you're interested, try out some of the challenges that I suggested because it would make for a much better tic-tac-toe program. But that's all for now.